Hi, welcome. This video will help you solve some inequalities, the most basic type. I do have another video that shows a little bit more advanced inequalities, and the main gist, I guess, is if you have experience solving equations, the steps are basically the same. We'll see one problem where that doesn't hold true, where there's something that you need to remember, and that's the topic that I explore a little bit more in my advanced video. So just for starting off, an inequality looks like this. That means less than. And there's three other ones that we could have in these sort of situations. We also have this one, which is greater than. And then after that, we also have less than or equal to, and then greater than or equal to. So those are the inequalities that you'll see that instead of having an equal sign like an equation has, we'll have that one of those four symbols. So let's just start off with that then. Let me just change up colors. Excuse me. Let's say that we have 3x plus 1 equals 13. Sorry, I didn't mean to write equals. That's just such a habit. The equal sign makes it an equation, and what we're trying to do is study inequalities here. Excuse me. So let's make that less than or equal to. So 3x plus 1 is less than or equal to 13. And when I teach equation solving, I encourage my students to put a wall down the equal sign, and I would do the same thing right through the inequalities. It helps you kind of keep things balanced. To get the x by itself, which is what we do when we solve one of these, we need to remove the 1 first. The 1 is being added on the left-hand side, so to move it across the wall to join the 13, we have to undo that addition. So we're going to subtract a 1. It's just like solving an equation. Now what we're going to do is we're going to rewrite, and we're going to see what we have left. We still have our 3x, we haven't touched it yet, but positive 1 minus 1 is gone. We still have our less than or equal to sign, and then 13 minus 1 gives us 12. So we do have one more step in this equation, in this inequality. To get the x by itself, we have to remove the 3. And the 3 is multiplying with the x. So to bring the 3 across the wall that we've built, we need to undo that, so we're going to divide. And again, the wall kind of helps you realize what we did here, we do over here. Same thing up top. We minus to 1, we minus to 1. It kind of gives you a good gut check. Am I following the right steps? On the left-hand side, the 3's cancel out. Technically, they give you a 1, but we don't usually write it. So we just have an x. The less than or equal to stays, and then 12 divided by 3 is 4. So our solution is x is less than or equal to 4. In real life, I would translate that to say all numbers less than or equal to 4 work for this inequality. All right, let's look at another one. Let's see, I think I'll switch back to blue. Let's say that we have 2 minus, I don't know, we'll say 6x, and then we'll say greater than, and to make this a number, let's say 20. Again, to solve, just to kind of keep yourself balanced, we'll draw the wall. And again, we have two things that we need to remove that are on the same side of the x. We have a 2 and we have a negative 6. This is a minus sign, but sometimes it switches over to a negative and it's attached to that 6. We'll kind of talk about that in just a minute. The 2 we need to remove. The 2 is positive, okay? This minus sign is attached to the 6. It's not really related to the 2. The 2 is positive, which means technically it's being added. So to bring it to the other side, we need to subtract. Do that on each side. 2 minus 2 goes to 0. And again, that minus sign is now a negative sign, and it's attached to that 6 still. 20 minus 2 gives us 18. And here's the oddball situation that I go into a little bit more in another video. We are going to be dividing both sides by a negative number. And the rule for that means that when we divide both sides, see here we're dividing by a negative, here we're dividing by a negative, we have to flip the inequality. So it started out as greater than, but because we divided both sides by a negative, we have to flip it. All right, our negative 6's cancel out. We do still have an x, and 18 divided by negative 6 is going to give us negative 3. So I would read the solution as x is less than negative 3, or all numbers less than negative 3 are solutions of this inequality. All right, let's try another. This one here, it's going to look a little bit scarier, I think, in the beginning. Let's say that we have x over 3 minus 5. We'll do greater than or equal to. And then we'll just do, I don't know, 6, I guess. Any number, really. So I'm just making these up. So again, to start the process, I would draw a wall. It just kind of helps keep you anchored about where the two sides are. It keeps you a little bit more aware of what you're doing to one side, you have to do to the other. So we have a 3 that we need to get rid of away from the x and a 5. Let's tackle the 5 first. It's the number that's standing all by itself, so it's being subtracted. So we're going to add 5. What we do to one side, we do to the other. The 5s will cancel out on the left-hand side. So when we rewrite, we have x over 3. We do not need to flip like we saw in the last one because we didn't divide by a negative. 6 plus 5 here gives us 11. Okay, so now we're ready to tackle the 3. And again, this could have been what was scary right in the beginning. A lot of times people see fractions, they're intimidating. But when you're in algebra, you can blow up any fraction you want by multiplying. How do you do that? Well, what's on the bottom of the fraction is what's causing the division. So the 3 is dividing. So if we multiply by 3, we are undoing that fraction. So to show your work, I would put a little times sign, usually a dot actually in algebra. We're multiplying by 3, which immediately cancels out. All right, and again, what we do on one side, we have to do to the other. And now let's rewrite. The 3's have canceled out, leaving a plain x. We don't flip anything. And 11 times 3 gives us 33. So all numbers greater than or equal to 33 will be solutions for this inequality. Let's look at one more like that, just so that, again, just to kind of get a sense of what we're doing. Let's say we have x. Let's say we have 2. Let's say we're going to add 7, and that equals 10. Oh, I wrote equals again. It's such a habit, especially being a math teacher. Let me re-put that. We'll do, I don't know, less than. Again, to start the problem, I would draw a wall down through my inequality. And we're going to remove the 7 first and bring it across the wall, so we're undoing addition. So we subtract 7. The 7's cancel out on the left. We have a less than sign, and then 10 minus 7 gives us 3. And again, to blow up this fraction, we have the 2 that's dividing. So how do we undo division? So we can show our work like that, immediately canceling out both of those 2's. We have to come over here and multiply that by 2 as well. On the left-hand side, the 2's are gone. We only have an x. Copy the less than sign, and 3 times 2 is 6. So all numbers less than 6 will be a solution for this. All right, I hope that helped. Again, this is just kind of the basics of solving inequalities, to reiterate that most steps are similar to solving equations, except like that second problem we saw. And I do have another video that shows multiple problems like that, so you can kind of get used to it. And I do believe I explained why you have to flip that inequality. But for now, this is a great start. Thank you.